On April 17, 2026, a command left Earth. It traveled at the speed of light, across 15 billion miles of empty space. It took 23 hours to arrive, and when it did, one of the last eyes Voyager 1 has left went dark. An instrument that had been running without interruption since 1977, since before most people watching this were born. NASA turned it off. Not because it failed, not because it was broken, because Voyager 1 is dying, and they needed to choose what gets to keep the rest of it alive. What you're about to hear is not just the story of a spacecraft, it's the story of the furthest thing humanity has ever touched. And what happens when we have to start letting go? Let's start with a number: 15.8 billion miles. That's how far Voyager 1 is from Earth right now. To put that in terms that actually mean something, if you drove a car at highway speed, without stopping, without sleeping, it would take you over 17 million years to get there. The light from the sun takes 8 minutes to reach Earth. It takes over 23 hours to reach Voyager 1. No human-made object has ever been further. Not even close. Voyager 1 launched on September 5, 1977, from Kennedy Space Center in Florida. Its original mission was simple: fly by Jupiter, fly by Saturn. Take some pictures, send them back. That was supposed to take about 4 years. Instead, it kept going, and going, and going. It photographed Jupiter's volcanic moon Io for the first time. It found active geysers on Triton. It sent back the pale blue dot. That photograph of Earth from 4 billion miles away, a single pixel of light surrounded by darkness, that Carl Sagan would describe as a mote of dust suspended in a sunbeam. In 2012, 35 years after launch, it crossed the heliopause, the boundary where the sun's influence ends and true interstellar space begins. Voyager 1 became the first human-made object to leave the solar system. It was never designed to do any of this. It has 3 million times less memory than a modern smartphone, and yet, it's still out there, still transmitting, still whispering signals back to us across the darkness. For now. Here's the thing nobody talks about when they talk about Voyager 1. It's been dying for years. Voyager 1 runs on 3 radioisotope thermoelectric generators, essentially nuclear batteries that convert the heat from decaying plutonium into electricity. When it launched, those generators produced about 470 watts of power. That sounds like a lot. It's about what a small microwave uses. But here's the problem. Every single year, Voyager 1 loses about 4 watts of power. 4 watts. Every year. For 49 years. As of right now, in May 2026, Voyager 1 is producing less than half the power it launched with. And the math is brutal. There is no way to recharge it. No way to slow the decay. No way to send a replacement battery across 15 billion miles of space. The engineers at NASA's Jet Propulsion Laboratory have known this was coming for decades. They've had a plan, a carefully ordered list of which instruments to turn off, in which sequence, to keep the most important things running as long as possible. Of the 10 science instruments Voyager 1 launched with, 7 have already been shut down. 7 eyes, gone dark, one by one, over the years. On April 17th, they turned off the 8th. The instrument they turned off is called the Low Energy Charged Particle Experiment, LECP. It's been running almost without interruption since September 1977, nearly 49 years. It measured cosmic rays, solar particles, the pressure and density of the space between stars. Data that literally no other instrument anywhere in existence could collect, because no other spacecraft has ever been this far from the sun. Kareem Badaruddin, the Voyager mission manager at JPL, said this when the decision was announced.
While shutting down a science instrument is not anybody's preference, it is the best option available.
Not anybody's preference. Think about what that means for a moment. These engineers have spent their careers, some of them their entire careers, working with this spacecraft. Some of them weren't alive when it launched. Some of them were in elementary school, and now they're turning off pieces of it, piece by piece, because they have to. Here's the detail that stopped me when I read it. Because Voyager 1 is more than 15 billion miles from Earth, the command to shut down the instrument took 23 hours to arrive. And then the shutdown process itself took another 3 hours and 15 minutes to complete. So the engineers sent the command on April 17th, and they didn't know if it worked until April 18th. They waited almost a full day to find out whether the message got through. That's not a technical detail. That's loneliness. That's what it means to be that far away. After the shutdown, Voyager 1 has exactly 2 science instruments still running. 2. One that listens to plasma waves, essentially eavesdropping on the sounds of interstellar space, and one that measures magnetic fields. That's it. That's all that's left of the 10 instruments that launched with it in 1977. But here's something the engineers were careful to mention. They left one small motor on the LECP running, a tiny motor that keeps one sensor slowly spinning, drawing just 0.5 watts of power. Less than an LED bulb. They left it on because if somehow they find extra power, if the Big Bang works, they want the chance to turn the instrument back on. They're not ready to say goodbye yet. The Big Bang. That's what the Voyager team is calling their last real attempt to save the mission. It's not a scientific term, it's a nickname, and the reason they call it that is exactly what you'd expect. It's all or nothing, everything, all at once. Here's the plan. Right now, both Voyager probes run on a mix of powered devices: heaters, receivers, transmitters, computers. Some of these devices draw more power than they need to. Some of them could be replaced by lower power alternatives. The Big Bang is a one-time coordinated swap. Turn off a whole group of high-power components simultaneously and turn on lower power alternatives to replace them. The word simultaneously is important, because when you're 15 billion miles from Earth, you can't do things one at a time and wait to see if each step worked. By the time you know whether step 1 succeeded, it might be too late for step 2. So you do everything at once, and then you wait. The team is testing the Big Bang on Voyager 2 first. Tests are planned for May and June 2026. Voyager 2 is slightly closer to Earth, about 13 billion miles away, and has a little more power, making it a safer test case. If it works on Voyager 2, they'll try it on Voyager 1 in July. If it works, the LECP might actually come back online. If it doesn't, it could end both missions at once. One command, 2 days to find out if it arrived, another 2 days to get confirmation it worked, and in between, silence. While all of this is happening, while the engineers are fighting to keep Voyager 1 alive, the spacecraft is approaching a milestone that has never been reached by anything built by human hands. On November 15, 2026, less than 7 months from now, Voyager 1 will be exactly 1 light day from Earth. 1 light day. The distance light travels in 24 hours, approximately 16 billion miles. And here's what that actually means for the people trying to keep it running. If you send a command to Voyager 1 on a Monday morning at 8 a.m., you won't get a response until Wednesday morning at 8 a.m., 2 days, for a single question and answer.
Susie Dodd, the Voyager project manager, described it this way. If I send a command and say, "Good morning Voyager 1 at 8 a.m. on Monday," I'm going to get Voyager 1's response back on Wednesday morning.
2 days. For good morning. It took Voyager 1 nearly 50 years to get that far. It took light 24 hours. And Voyager 2, its twin, launched 2 weeks later, won't reach that same distance until 2035. The most optimistic estimates say Voyager 2 probably won't be operating then. Voyager 1 will be the only one, the only human-made object to ever cross that line. On February 14, 1990, Valentine's Day, Voyager 1 was 4 billion miles from Earth. Carl Sagan had lobbied NASA for years to turn the camera around, to take one last picture before the cameras were shut off forever. They agreed. Voyager 1 turned around, and it took 60 photographs, a mosaic, a portrait of the solar system from the outside looking in. In one of those photographs, in a scattered ray of sunlight, there is a tiny dot, less than a pixel. That dot is Earth. Every person who ever lived, every war ever fought, every kindness ever shown, every mountain, every ocean, every city, every love story, every tragedy, every moment of our entire history, a pixel, in a ray of light. Carl Sagan wrote about it in 1994. And nothing I could say would improve on his words. He said our planet is a lonely speck in the great enveloping cosmic dark. He said there is no hint that help will come from elsewhere to save us from ourselves. He said,